Hello, welcome to Virginia Transformer Corporation. Today I would like to introduce our newest product called VCM2. VCM2 stands for Virginia Control Module. VCM2 can measure and monitor the transformer parameters such as oil temperature, winding temperature, liquid level, pressure and ambient temperature. In addition, it provides all the information at one place on this screen. This screen is available locally on the device and it can be accessed from your computer. It allows the users to access the data remotely and the data can be downloaded for analysis. All the output contacts can be available at remote location for annunciator, SCADA and other display and protection purposes. Now I will show you the test setup for VCM2. For this demonstration, we have built a transformer model. On this model, we have installed various analog gauges such as pressure relief device, shut-in pressure relay, liquid level gauge, winding temperature gauge, liquid temperature gauge, pressure vacuum gauge and VCM2 sensors. The main purpose of this test setup is to compare and verify the gauge results with the VCM2 results and also to demonstrate how this VCM2 works under actual conditions. VCM2 uses various sensors to measure oil temperature, winding temperature, liquid level, pressure and ambient temperature. All the outputs from the sensor are connected to the VCM2 and various outputs are displayed on the screen. Based on the set points, the VCM2 activates the alarm contacts. Now I will demonstrate how VCM2 can measure and monitor the transformer's liquid temperature. We have used a Qualitrol liquid temperature gauge to compare the VCM2 results. Our model is at ambient temperature, so the oil is also at ambient temperature. You can see the gauge shows the oil temperature as 29 and the VCM2 shows the reading as 29.7. Also you can see here we have various set points for fan stage 1, fan stage 2, alarm and trip. The alarm is deactivated because the measured value is less than the set value. These set points can easily adjusted on the screen. Now I will show you how to change the set points using this screen. To do that, click on the text box and enter the new set point. Click enter. You can see the alarm is activated because the measured value is more than the set value. Please note that these set points can be easily changed from your computer. Similarly, we can monitor the transformer's winding temperature using the VCM2. We have used a perfect control winding temperature gauge to compare the VCM2 results. You can see the gauge shows the reading as 29 degrees and the VCM2 shows the reading as 29.7 degrees. Also, if you click on this temperature configuration, you have an option to change the fan's activation based on top oil temperature or winding temperature. The major advantage is that it has the ability to control the activation of fans based on oil temperature or winding temperature from local as well as the remote location. One of the unique features of the VCM2 is the pressure monitoring. Now I will demonstrate how VCM2 can monitor the pressure. As you see, we have various set points for low pressure and high pressure. The low pressure set point is set at -7 psi and the high pressure alarm is set at 8 psi. You can see the gauge shows the reading as 1.5 psi and the VCM shows 1.5 psi. So both are same. Now I will simulate the pressure to more than 8 psi to activate the high pressure alarm. You can see as the pressure exceeds more than 8 psi, the high pressure alarm has been activated. Similarly, you can activate the low pressure alarm by reducing the pressure. Please note that these set points can be edited easily using your computer. Thank you. Now I will show you how VCM2 can detect the operation of pressure relief device. When the pressure inside the transformer goes more than 10 psi, the pressure relief device operates and it releases the pressure. When the PID is activated, the alarm on the VCM2 screen is visible. Now I will simulate the pressure to more than 10 psi to activate the pressure relief device. I will use this air hose to change the pressure. As you can see, when the PID is activated, the PID alarm on the screen is activated. So even if using the VCM2 at remote location, the PID activation can be detected. Once the PID is activated, it needs to be reset manually on the transformer. Likewise, the PID alarm on the VCM2 screen needs to be reset. Now I will demonstrate how VCM2 can detect the sudden change in the pressure. We have used a ceiling relay to compare the VCM2 results. VCM2 uses sensor to detect the sudden change in the pressure. The conventional method uses sudden pressure relay and ceiling relay. When the pressure inside the transformer goes more than 2 psi per second, the SPR will be activated and the ceiling relay will detect the SPR activation and it latches the signal. Now I will simulate the change in pressure to more than 2 psi per second to activate the SPR using this air hose. You can see when the SPR is activated, the SPR action is latched by ceiling relay and the ceiling relay is activated. So once the ceiling relay is activated, it needs to be reset using this button. Similarly, you need to reset using this button here. Now I will demonstrate how the VCM2 monitors the transformer's liquid level. We will compare the 25 degrees centigrade liquid level reading on the VCM2 screen with the reading of the liquid level gauge. With the conventional system, the analog gauge shows the low level, high level and 25 degrees centigrade level. Also, the alarm contacts are activated when it exceeds the low level or high level. This is the only information available on the gauge. Whereas in VCM, it provides the liquid level in inches. It provides the current liquid level in inches. There is also a physical indication on the screen as a graph display. Any change in the liquid level can be monitored using the VCM2. Alarm indications will be displayed for the liquid level reaching its set points. A major advantage of the VCM2 is that you can monitor the liquid level remotely. If the level goes down or up, we can adjust the settings before the alarm is activated. So, proactive maintenance is possible with the VCM2. That concludes the demonstration of VCM2. We are excited to introduce this next step in transformer monitoring. We have provided an option of local and remote access for key parameters. This is a great value added for your transformers performance analysis and preventive maintenance. Thanks for your time. Remember, VTC provides custom solutions.